Hi, welcome to week three's big group hangout. Today we are going to be talking about a teaching technique that uses dice to help students understand the concept of randomness. I'm Elisa Cundiff. I teach computer science at Las Cruces High School. And
I'm Melody Hageman. I teach computer science at Centennial High School.
And I'm Lauren Curry. I teach computer science at Las Cruces High School as well.
And our activities fall into the use and modify phases of the use, modify, create cycle, which you may recall from the week two. This is a methodology used to scaffold the use of computer models for better student learning. As a group, we found that one of the most useful activities for introducing students to the concept of randomness in programming is the dice and data activity that you'll find in this week's resources. Dice and data provides a wonderful visual for students to see an example of both uniform distribution, which will be used for random walk, and for triangular distribution, which is used for wiggle walk in this week's lab.
Students are broken up in this activity into small groups of 2 to 3 and are given 2 dice. First, they're asked to roll one die 50 times and record their results. This takes a bit of time. The next, they're asked to roll both dice 50 times and record the sum of the 2 dice. And then that also takes a bit of time. And you should allow about 15 minutes for this portion. And I have a kind of favorite tip for this activity. I like to give the students a cup along with their dice. And they stick the dice into the cup, they shake the dice in the cup, and then they look at the value that the dice rolled while they're still in the cup. And because the dice never leave the cup, no time gets wasted with students chasing dice all over the floor and the tables.
So once your students have rolled their die 50 times with 1 dice and 50 times with 2 dice, you can model their results on a board, a whiteboard or a chalkboard, and it gives them a very good idea of what both uniform distribution and triangular distribution look like. So what I do in my class is I label board 1 through 6 on the side, and then I have students call out their results, and I tally the amount of times each group rolled 1, 2, 3, 4, 5, and 6. And this is for just 1 die. And you'll notice that as your students' results are read, each number, because it has an equal probability of being called, kind of lines up evenly. And you can show them that this is a uniform distribution of data. Once they have done their data for both die, oops, sorry about that, you can have them record, you can do the same thing with their 2 dice, 2 through 12 on the side, and you'll notice that, of course, 5, 6, 7, 8, 9, 10 that have more probability of being rolled because there's more combinations that exist have more tally marks, and you can show them really clearly that this is a triangular distribution of data. Now let's address some common questions that have come up in our smaller facilitator groups. So this week in one of my facilitation groups, there was a question about the random generation of plankton and how accurate that is of an abstraction. And a lot of my group members wanted to find different ways of doing this. And they did come up with creative ways to do this. They looked at their neighbors around them and thought, well, plankton can grow more plentifully if there's space. So you can look at your neighbor's for command and see if there's space around your neighbors and grow from there. That's just one of the suggestions we came up with.
So I think that's it for questions. Coming up this week, we will be focusing on CS Principles Big Idea number 2, which is abstraction. We'll learn about abstraction and multiple layers of abstraction, and teachers will explore the use of abstraction to reduce the complexity of a problem. So please tune in with us next Monday, the 23rd of November, for our next Hangout on Air. And until then, please reach out to us, your facilitator groups, or on the forum if you have any questions.